Welcome back, folks. In today's class, we will talk about the vectors, and in vectors, you need to do only some specific questions. I will encourage you to do question number 21 from from 21 up to 27 or 28 on exercise 9.3. If you can do those questions, you should be good to go. Now I'm going to take the question number 25. So if you can understand one of the questions, you will be able to understand remaining of the questions too. So if I'm given the vectors, this is what's given to me. One vector is 318 meter. Another vector given to me is 245, which is like this. Oops, this is way too dark. It end up erasing the other line too. So let me see if this is sharp or not. Now better, 245. And then angle given to me here is, this angle is 16.3 degrees. Now what I'm going to do is, to find out the resultant vector, first of all I'll move these two vector on the separate vector diagram. I just want to show this pink diagram. You can move it towards the right hand side like this. So if this angle is 16.3, this angle is 16.3 degrees. And now let's draw them on the separate diagrams. So the very first one, which is 318, this one is at an angle of 67.5 degrees with respect to the horizontal surface, this surface. Now one thing I will always do is, I will always take the angle with respect to the horizontal surface. If you want to take it with respect to the vertical also, go ahead and do that. And but I like to keep the angle with respect to the horizontal surface. What do I mean by that? Now this second vector, I'm gonna move it with respect to the horizontal surface. So this angle was 16.3, so this angle will convert into 16.3 minus 90. So 90 minus 16.3, which is 73.7. So this angle will come out to be 73.7 degrees. This is 245. Now I'm going to find the component of these two vectors. So this has a component towards the left hand side, and this all has a component towards the upward side. These are the components. So this is r1x. Let's say this is r1, and this one will be r1y, and this is r2, and this is r2x, r2x, and this value will be r2y, r2y. All right, now let's look into this, how we're going to solve this question. So this is 318, uh, cos of this angle is 67. So r1x, cos of 67.5. Now if the angle is with respect to the horizontal surface, listen me carefully. If the angle is with respect to the horizontal surface, this surface, then you can always represent this one with the hypotenuse times cos of the given angle. Hypotenuse times cos of the given angle. And r1y value will be equal to hypotenuse times sine of given angle, 67.5. If this is with respect to the vertical, so they will flip. So if this was the angle theta, then this surface, this will be represented with cos times cos of angle times the hypotenuse, and this value will be hypotenuse times sine of given angle, which is, so this is the horizontal here, this is the vertical here. All right, hopefully you were able to understand that concept. Now here I've changed the angle again with respect to the horizontal surface. So here I will write it as r1, r2x, which is 245. This is cos of 73.7, so this is this one, and r2y, which is 245, sine of 73.7 degrees. Now if I see them carefully, this r1y, this one is a positive because this is upward, but r1x is a negative number because this is acting towards the left hand side, so I should place a negative here. And these two are positives, so these both will remain as positive. So let's see the values for R1X, R1X and R1Y. What the values are. So 318, 318 cos of 67.5. Cos of 67.5, which is 121 negative, negative 121.7. And then R1Y is equal to, which is equal to 318 sine of 67.5, which is equal to 293.8 approximately. So R2X, which is equal to 245 cos of 73.7, which is 68. R2X is 68.8. R2Y value is equal to 245 sine of 73.7, which is 235.2 approximately, and these are positive numbers. Now I'm going to try and find out R1. I'm going to try and find an R1 net, R1X, not R, I should say RX net. So that will be equal to R1X plus R2X. So this is negative 121.7 plus 68.8. And that's going to give you 121.7 minus 68.6, which is negative 53.1 degrees. And R1, RY net, the both will add up. One is 293, 293.8 plus 235.2. So this value will be 298, 93.8 plus 235.2, which is 529, 529.3. And now I will draw them again on the vector diagram. This is 529, which is y component. This is like this, and x component is, I'm putting a degree here, so this is 53.1. Now a lot of students make a mistake here. They end up drawing the resultant like this. Please don't do this. Your answer will be wrong because the direction will be wrong. If vectors, your resultant vector, let me tell you simply, is can be like this, like this, like this, or like this. If your vectors are these two, it will be like this. If your vector are these two, these two, then it will be like this. If your vectors are these two, your vector, resultant vector will be this. If your vectors are these two, then your final resultant vector will be like this. So in this case, it will be like this, outwards. So now R value will be equal to square root of 529.3 square plus 53.1 square. And if I do the math, it will come out to be, let's do 529.3 square plus 53.1 square, and then square root of that number. Square root of that number, 531 is the R value I got, 531. Let me just quickly see the answer here, because last time when I was doing this question, I accidentally make a mistake and I got the wrong value. This time around, it should be pretty good. So chapter number 9, chapter number 9.3, question number 25, which is 531.95. So 95, I got the value, which we can round up to 532, 532. Now I have to find the angle also, tangent theta, which is equal to opposite, which is this value, 529.3. So this is, because why I've taken this as 529, because this is the y value, r net y, or ry net, whatever you call it. This is y component divided by 53.1. So, so the value will be 529.3 divided by 53.1, and then second function tangent inverse of this value, which is 84 degrees. Theta value will be equal to 84.3 degrees approximately, which I can change it then to the principal angle, because this angle is 84.3 degrees. I will change it to this angle now. So principal angle will be equal to 180 degree minus 84.3 degrees. So that's going to give me this angle. That's 180, which is 95. Theta angle comes out to be 95.7 degrees approximately. And the resultant is 532. So we got the final answer. So a couple of things you need to remember in this kind of a question is always draw the diagram, always draw the diagram, and then vector, resultant vector is always outwards. And if you have any other questions, you can email me or please come and see me in tutorial so that I can help you with these questions. So again, if the kind of a question I did, please make sure you do similar questions like this. And I'll see you with another lecture video. Till then, goodbye.